All right, so if we're going to add and subtract rational expressions, or add and subtract fractions, the rule that you have to follow here is that in order to add and subtract fractions, they have to have a common denominator. And sometimes they're nice to us, and they go ahead and give us something with a common denominator. Like 7 over 4x plus 3 over 4x. Denominators are already the same. So when you add fractions, you just add the numerators. 7 plus 3, 10. And then after you've done that, you need to look to see if you can reduce that sum. Well, 10 and 4 have what in common? 2. So divide them both by 2. And that's going to turn into 5 over 2x. And we've added fractions. They already had a common denominator. The key things to notice about the denominators are the factors that are there. They have the same two factors, 4 and x. As we start building some of these that don't have the same factors, you got to pay attention to what factors you need or don't need. Here's a subtraction problem. We got 10 over x plus 3 minus 17 over x plus 3. Denominators are already the same, so we just subtract the numerators. 10 minus 17 be negative 7. The denominator doesn't change. And then will this reduce? Negative 7 over x plus 3. Nothing in common between them, so it does not reduce. Do another one with a common denominator. X plus 2 plus 4 over x plus 2. So 2x over x plus 2 plus 4 over x plus 2. Be 2x plus 4 over x plus 2. So they weren't like terms, so I couldn't combine them to make 6x because they're not, one's an x and one is not. Then we want to look at that and say, okay, can I reduce that fraction? So if we're going to reduce this, we need to factor anything that'll factor. Well, the numerator factors how? Yeah, 2 parentheses x plus 2. And we have an x plus 2 on the bottom. So those two cancel each other out. That one turns out to just be 2. I was looking to simplify if possible. Maybe it's 4x minus, or 4x over x plus, or excuse me, 4x over x minus 3 minus 12 over x minus 3. Well, denominator's already the same, so you just do the work at the top. 4x minus 12 is just 4x minus 12. X minus 3 there. So, will the numerator factor? All right, so 4 parentheses x minus 3. That's kind of handy because that denominator is x minus 3. And that means they cancel. And that one ends up just being 4. About 16x squared over 4x plus 5 minus 25 over 4x plus 5. Well, denominator's already the same, so I can go ahead and subtract 16x squared minus 25 over 4x plus 5. And then we always, when we add and subtract fractions or multiply fractions, we're always looking to reduce anytime we got fractions. So will the numerator or the denominator factor here? How? Because it's a difference of squares. What cancels? Yeah, 4x plus 5 cancels 4x plus 5, and then we have 4x minus 5 left on the top. Technically, what's in the denominator? 1. But we don't have to write that. Okay, so if the denominator is the same, you're going to go ahead and do your operation and then look to factor or simplify the fraction. Okay, that's if the denominator is already the same. Now, if the denominator is not the same, you got to make it the same so that you can do the operation. Okay, so let's get into those kind. And say we had 3/7 plus 5 over x squared. So, fairly simple one to start off with. Really obvious that these two denominators are not the same. Right? And this one's easier because they don't share anything. The denominator 7 doesn't have anything that the denominator over here has. So the common denominator, or the least common denominator, is what we want to find. And I always kind of just do that off to the side and say, okay, well, do they share anything? No. Then that means it needs a 7 and an x squared. Okay, so the common denominator should be 7x squared. What does the first fraction need? It needs the x squared. So I'm going to multiply the bottom times x squared, but I also have to multiply the top times x squared. So that would get me 3x squared over 7x squared. What does the second fraction need? It needs the 7. So I multiply the bottom times 7, but I also got to multiply the top times the same thing. So that's going to give me 35 over 7x squared. Now I've got a problem where the denominators are the same, so I can do my operation. It's 3x squared plus 35 over 7x squared. Will this factor? 3x squared plus 35, will it factor any? There's nothing in common between 3 and 35, and there's no x in common. So, does this x squared cancel that x squared? No. This one is tied to this part up here by the addition. You can't just cancel parts. You've got to be able to factor it to cancel parts. And since it wouldn't factor at all, that's all we can do. Get that answer. Let's get one that's already in factored form in the denominator. 8 over x times x plus 2 plus 9 over x. All right, so when you go to do this sort of problem, you got to have a common denominator because it's addition of fractions. So you look for the denominators, and this one's already in factored form, so I don't have to do any factoring for either of the denominators. We'll get to those that do. But the first thing you always want to look for when you're trying to find the least common denominator is what do they share? What do they have in common? Yeah, this x and this x are in common. So that's got to be part of your least common denominator is that shared piece. So you got the shared piece of an x, and then what's the piece that's not shared? So that's got to be part of the least common denominator as well. Okay? So if they share a piece, you only have to list that once. Okay? So any shared piece is only listed once in the least common denominator, and then you get the other pieces. Okay? So does the first fraction need anything? No, it's got both pieces for the least common denominator. What does the second fraction need? It needs the x plus 2. It's already got the x in the denominator, so it needs the x plus 2. So it gets it on the bottom and the top. Always going to happen like that. Okay, so that gives us 8 over x plus 2, plus 9. We'll go ahead and do parentheses, x plus 2 over x plus 2. What can happen here? Yeah, that would turn into 9x plus 18. And then when I add, do I have any like terms to the 8? The 18, right? So 8 plus 18 be 9x plus 26 over x plus 2. and then you look to see if you can simplify that. Do 9x and 26 have anything in common? No. If that won't factor, then that means I can't simplify. Sometimes even if it does factor, we can't simplify, but we've got to look for that. Okay? Let's look at another one. So we had 7x over x squared plus 3x minus 3 over x plus 3. Now, the difference in this problem or a couple of differences in this one and the previous problem, one is that it's subtraction. That really isn't the big deal. The biggest deal is to look at the denominators. You got x squared plus 3x and then an x plus 3. Oh. Sounds good. It's just the empty trays. Thank God. All right. Okay, so before you in order to find your least common denominator, you've got to factor the denominators, if they will. Will this factor any? As x and x plus 3. Does this factor any further? No. Okay? So the denominator here is x times x plus 3. The denominator here is just x plus 3. What part do they share? So that's got to be part of the least common denominator. What part do they not share? That x. Okay? So does this first one need anything? It's got both pieces, right? The second one needs what? So multiply by x on top and bottom. So we have 7x over x plus 3 minus 3x over x plus 3. Common denominator has been found. We do the operation then. What's 7x minus 3x? 4x. X plus 3. Will that simplify any? And an x and an x there, right? They'll cancel each other out. 4 over x plus 3. Thank you. So this one a little bit more involved. We got to think a little bit. Which one of those looks like it should factor? Bottom on the second, right? So that would factor how? 3x is the GCF and leaving x plus 1 in the parentheses. Now, when we go to find our least common denominator, what do they share? 3 and an x, because 3 goes into 9, right? Okay, so they share a 3 and an x. What do they have that's not shared? An x plus 1 and another x and another 3. Because what makes 9x squared? 3x and 3x, right? There's two 3x's there. So really, maybe it makes more sense if I write it 3x, x plus 1. But when you go to do the work, 3x times 3x is 9x squared, right? So this is what we want our denominator to look like, 9x squared times x plus 1. What does the second fraction need to turn this into a 9x squared? it needs a 3 to turn that into a 9, and it needs another x to turn that into x squared. So the top needs that as well. What does this fraction need to get that common denominator over there? It just needs the x plus 1. So that'd be 7x plus 7 over 9x squared, x plus 1, plus 3x squared over 9x squared, x plus 1. Add them together. Are there any like terms in the numerator? No. So just put it in descending order. 3x squared plus 7x plus 7 over 9x squared, x plus 1. We got a trinomial up top. We need to try to factor it if it's possible. So multiply 3 and 7 is 21. Is there anything that multiplies to be 21 and adds to be 7? 7 and 3 adds to be 10. 21 and 1 adds to be 22. That's only factors of 21 there are. So that numerator doesn't even factor. So then that means I'm done. If the numerator won't factor, then there's nothing you can do to simplify it. Okay. I'll scroll back up and you can still see the bottom. I'll write the next problem. X plus 3 over x plus 4, x minus 1, minus 2x minus 5 over x plus 2, x plus 4. So already in factored form for us. So that's going to help us maybe find the least common denominator. So what do we look for first when we're finding the least common denominator? What the two fractions have in common? What do they share? They share an x plus 4. So we know that's got to be there. And then, so that's this piece and this piece. The next thing you got to have is what do they not share? They don't share this piece and they don't share that piece. So they got to be there too. X minus 1, x plus 2. Okay. Which piece does this fraction need? It needs the x plus 2. So the top gets the x plus 2 as well. What part does this one need? X minus 1. The top gets x minus 1 as well. We're going to multiply that out. X squared plus 5x plus 6. And then I'm going to write my least common denominator there. Doesn't matter what order you write that in. Minus, and then we need to multiply this one out. So 2x squared minus 7x plus 5. Then x plus 4. X minus 1. X plus 2. 2x times x is 2x squared. 2x times negative 1 is negative 2x. Negative 5 times x is negative 5x. That together is negative 7x. And negative 5 times negative 1 is positive 5. Now, here's the thing that catches most people on this problem. If they get the common denominator right and they've multiplied all this out, this is the minus sign in the middle can catch a lot of folks because you're subtracting that entire numerator, not just the first piece. So it's a minus sign over the whole thing. So you got x squared minus 2x squared, which would be negative x squared. We have 5x minus negative 7x, which makes what? Positive 12x. Positive 5 minus a negative 7. Double negative makes it plus. 6 minus 5. 1. No x's, just a 1. And then the denominator we're leaving in the factored form. We try to factor this. -1 times 1 is -1. Is there anything multiplies to be -1 has to be 12? Absolutely not. So there's nothing we can, if the top won't factor, then there's no simplifying that can happen. That subtraction is usually what catches folks on that last piece if they get all the denominator stuff right. That one was already in factored form when they gave it to us. Let's get to the toughest ones, the ones where they're not in factored form. All right. So if they're not in factored form in the denominators, what do you have to do? Factor them. Okay. So let's factor that first one. Yeah, good. X plus 2 and x plus 2. The second one, x plus 2 and x minus 2. The difference of squares. Now, least common denominator, what do they share? An x plus 2. One x plus 2 is shared. What's not shared? Another x plus 2 and the x minus 2. So there should be 3 factors in the denominators of both of them when we get done. What does the first one need? Needs that x minus 2. The top gets the x minus 2 as well. What's the second one need? Needs that second x plus 2. So there's our common denominator. Got 2x plus 2's and an x minus 2. This one's got 2x plus 2's and an x minus 2. Well, that's what our common denominator should be there. And then multiply it out. X times x is x squared. X times 1 is 1. X. Negative 2 times x is negative 2x. So that's negative x minus 2. And then x plus 2. X plus 2, x minus 2. You could write that x plus 2 squared if you wanted to. It doesn't help you any, but you could. And this would be 6x plus 12. And x plus 2, x plus 2, x minus 2. Subtraction. Again, be careful because it's subtracting this entire numerator, not just the first piece. So it's x squared minus, there's no other like terms there, so that's just x squared. Negative x minus 6x would be negative 7x. And then negative 2 minus positive 12 would be negative 14. And then x plus 2, x plus 2, x minus 2. Does this trinomial factor? Multiply to be negative 14 and add to be negative 7. My options are negative 14 and 1 or negative 7 and 2. Neither of those work. So I'm done. The name of your factoring is it's a very thing, I made mention of this before. Factoring is a pretty big skill. Without it, it makes everything harder or almost impossible. So you got to factor your denominators, find the shared piece, and then whatever the shared piece is, get a copy of that, and then the pieces that are not shared for your least common denominator. That's what you need for a least common denominator. They're not going to get just super crazy on the denominators and make it a really, really tough factoring job for you. They don't. At this level. Now you get to college algebra, they get a little tougher, but still not impossible. It's the same idea. All right. Now, last thing we got is thing called complex fractions. And they're called complex because they look really complex. But I'm going to break them down for you. They're not really that bad. They look horrible. Yeah. 5 over x plus 4. Let me get a bigger marker. Over 1 over x plus 4 plus 2 over x. That looks nasty, but it's not. It's really not that bad. Okay? It's really what's this big bar right here? It's a fraction bar, but it really means what operation? Divide. So you really just have this thing divided by this. So if we can simplify this part into one fraction, then it's just flip it and multiply. Okay? So let's get to simplifying this piece. In order to add those two, what do we have to have? Common denominator. Do I need to factor either of them? No, not on this one. There's nothing that'll factor. So what would be the least common denominator for that bottom part? X plus 4 times x. Technically, they don't share an x because this is tied to the plus 4. It's like a separate x. Okay? X and x plus 4. So the first fraction needs what? Times x. Second fraction needs an x plus 4. So top part's not changing. 5 over x plus 4 over. Yes, sir. Because when you add 4 to a numerator and a denominator, it doesn't necessarily make it equal. Multiplying by the same thing is the only way to keep fractions equal. Because, like, take for instance 7 over 8. 7/8. If I added 4 to the numerator, that'd be 11. And then if I added 4 to the denominator, that'd be 12. Is 11 over 12 equal to 7 over 8? No, not at all. So adding something to a denominator and then to a numerator doesn't keep it equal. Multiplying, what we're really multiplying by here is x plus 4 over x plus 4, which is actually 1. So we're multiplying this fraction by 1, so it keeps it the same value. It just changes its looks. Okay, so you can't just add something to it. You have to multiply to get denominators the same. No, adding and subtracting is not a legal way to get denominators the same. So this would be x times x plus 4 plus 2x plus 8 over x times x plus 4. And then we want to simplify that denominator. This big piece here, we're going to do that addition. X plus 2x is 3x. So we end up with 5 over x plus 4 over 3x plus 8 over x plus 4. Now, what did we say this big thick bar was? It's division. It's this divided by that. So we flip the bottom one and multiply. That's 5 over x plus 4 times x plus 4 over 3x plus 8. And then the rules from yesterday's stuff. Diagonally cancel x plus 4s. This, nothing else will cancel, so it's just 5x over 3x plus 8. It's complex fractions. Don't expect it to be just cake, but expect it to, they're going to work out kind of nice there. They're not going to get crazy on the complex fractions with you in Algebra 2. I mean, that's, you get to calculus or, pre-cal or something like that, they get a little more intense. They're not going to get crazy with it in this one. Let's do one more of those and then we'll be done. Got time to go anyway. 6 over x minus 5. And then the bottom part's 3 over x minus 2x over x minus 5. There's our big fraction bar. What's the common denominator in the denominator? X and x minus 5. This is an x and this is a separate x because it's tied to the minus 5. So what's the first fraction need? X minus 5. Second fraction needs an x. So that's going to give us the top part being the same. Bottom part, 3x minus 15, x minus 5, minus 2x squared, x minus 5. Simplify the denominator. 6 over x minus 5 is the same on the top. Negative 2x squared plus 3x minus 15 over x minus 5. I'll darken in that middle fraction bar. Does that factor? Multiply to be 30 and add to be 3. 3 and 10 is 13. 6 and 5 is 11. 30 and 1 is 31. None of that works. So it doesn't factor. So we can't simplify the denominator yet. So we're going to flip and multiply. 6 over x minus 5 times x minus 5 over that trinomial that would not factor. Stuff that cancels. 6x over negative 2x squared plus 3x minus 15. You won't have a lot of complex fractions. I mean, that's not, you'll have more of the regular ones, but there are a few of those that show up. I want to think folks said that there might have been one of those on the practice. You'll see, I'm not sure. Can't remember.